All right, in this video, we are going to work through the following example. It says you are given that the cosine of A equals negative 7/25 with A in quadrant 3, and cosine of B equals negative 3/5 with B in quadrant 2. Find the sine of A plus B. Give your answer as a fraction. So we know that we want to find the sine of A plus B here, right? So that's pretty much a giveaway that you want to use the sum identity for sine. So this identity here, right, with A playing the role of X and B playing the role of Y. So you can see over on the right-hand side, there are some things that we need to know. We would need to know what the sine of A is, what the cosine of B is, what the cosine of A is, and the cosine of B. So we would need to know all four of those things. If you look in the problem, though, the issue is that they don't tell you all four of those things. They tell you the cosine of A and the cosine of B, but they don't tell us what the sine of A is, and they don't tell us what the sine of B is. So the very first thing that we are going to have to do is to go figure that out, okay? All right, so before we do anything, I'm going to go over here and start calculating out those things. So let's start with A, and we're going to use the fundamental identity, right, that the cosine squared of A, oops, let's start that a little higher up, that the cosine squared of A plus the sine squared of A equals 1, right? The fundamental identity. And so we know we are given that the cosine of A is negative 7/25, right? So we're going to go into this identity, and for cosine A, we are going to put negative 7/25. Don't forget that in the identity, it is cosine squared. So we have to square the cosine of A when we do that. All right, so that's going to allow us to solve for the sine. In order to do that, first, though, we'll solve for the sine squared. So negative 7/25 squared, that would be negative 7 squared over 25 squared plus sine squared A. Right, when you're squaring a fraction, it means multiply it by itself. So you multiply the tops, so that's negative 7 times negative 7. On the bottom, you get 25 times 25. So negative 7 squared is 49. And then 25 squared is 625. Okay, 625. All right, and so then that's what I've got. So next up, I want to subtract 49 625s from both sides. So on the left side, I'll get sine squared A equals, all right, oops, I wrote that backwards, sorry. All right, and then I need to subtract 49 625 from 1. So I need a common denominator. Of course, that is going to be 625. Right, so 1 is equal to 625s over 625s. And then now I need to subtract these two fractions. Right, so 625 minus 49, that would be the top number. And that is going to be 5. Let's see. I'll just do this over here quickly just to make sure I don't mess it up. So 625 minus 49 is 576, yeah, over 625. All right, so that's 625 minus 49. It's 576 on top. And then we keep it over the same denominator here. All right, and so now I have solved for sine squared. What I need to do is to take and use the square root property. The square root property says if I have some expression squared equaling a positive number, well, then there are two solutions to that equation. And that is plus or minus the square root all right, and so I need to reduce that. The square root of 576/25, right, is going to be the same as the square root of 576 over the square root of 625. Okay. All right, and the square root of 576 is 24, I believe. And the square root of 625 is 25. Okay. So we've solved for sine A, but we have these two answers, plus 25, plus 24/25, and minus 24/25, and we need to pick one of those, right? And the way that you pick one, right, is by drawing the angle out. So here is our angle in standard position, right, like so, and we are given that the angle A is in quadrant 3, right? So quadrant 3 is this quadrant down here. And so if you look at the points, right, on the terminal side down in quadrant 3, those points on there would have both negative coordinates, right? Because to get down in quadrant 3, you would have to go to the left into the negative x's and then down into the negative y's, right? So any point on that terminal side that's down in the third quadrant is going to have two negative coordinates. Well, if you think about that, that's where the sine and cosine come from, where the terminal side hits the unit circle. And so therefore the correct answer here is the negative answer. So we know that sine of A is equal to negative 24/25. Okay? And I'm going to write that down over here because I need some more room. And we'll need to write that down. Okay, so I have the sine of A. That's one more piece of information that I need. The other thing I need is the sine of B, right? So I am basically going to repeat this entire process again, okay? And so let's go ahead and do that. So again, we are going to start off with that same fundamental identity. Cosine squared A plus sine squared A equals 1. Oops, except it's with B now, so I'll have to fix that. And this time we are given that the cosine of B is negative 3/5. All right, and don't forget that squared. All right, and so now we work through the same steps, right? To square this out, negative 3/5, we would square the negative 3, which is 9. we would square the 5, which is 25. All right, next step then, it would be to get sine squared b by itself on one side of the equation, and we could do that by subtracting 9/25 from both sides. All right, so over on the left-hand side, we would just be left with sine squared b. Over on the right-hand side, we have 1 minus 9/25. Well, again, we would get a common denominator. Okay, so 1 is the same as 25/25. So 1 minus 9/25 is 25/25 minus 9/25. All right, so now we're trying to subtract two fractions with common denominators. So we just subtract the numerators. 25 minus 9 is 16. And keep it over the same denominator, right, which is 25. So now we have sine squared b by itself, right, on one side of the equation. Then we use the square root property that says, well, if sine squared b is equal to 16/25, then there are two possibilities for sine b. It's either plus or minus the square root of 16/25. All right, and then we can simplify that square root as much as possible. That's going to be the square root of 16 over the square root of 25. The square root of 16 is positive 4, and the square root of 25 is 5. All right. So we have, again, two possibilities for the sine of b, right? And so we have to make the decision. Which one do we choose? And we do that just like before, right? We draw a picture of the angle. So b, right, in standard position, the initial side's over here. And then it tells us in the problem, right, that the cosine of b is -3/5 with b in quadrant 2, right? So quadrant 2 is this quadrant up here. And then we would look at a point on the terminal side. And in quadrant 2, right, the points in quadrant 2 will have a negative first coordinate and a positive second coordinate, right? And so we're talking about the sine, right? That's given by the second coordinate. So the correct choice here between the minus and the plus is the plus, right? For a quadrant 2 angle, they have positive signs. So it's positive 4/5 on the answer. Okay? All right, so I'm going to write that down for future reference. All right, and so now that we have all of the information we need, we can go ahead and now start computing the sine of a plus b. All right, so I am going to erase this. And we are going to go back to our sum formulas. We want the sine of a plus b. So this is the formula that we are going to use. Okay, so starting with the sine of a plus b, all right, we know that that is equal to sine a cosine b plus cosine a sine b. All right, and now we know what all of these values are. We know that sine of A is negative 24/25, right? We calculated that earlier. We know that cosine of B, that was given to us as negative 3/5. All right, so negative 3/5 for cosine B, and then the plus. And next up is cosine A, that was given to us, right? That's negative 7/25. And then sine B was a value that we calculated out to be 4/5. Okay, so that's what we would get. All right, and then we just carry out these multiplications. So negative 20, we'd multiply these two fractions, so we just multiply the numerators. Negative 24 times negative 3 is 72, I believe. Positive 72. That'd be 60 plus 12, right? And then 25 times 5 would be 125. Right, just like if you had 5 quarters, you'd have $1.25. And then negative 7 times 4 would be negative 28. So I'm just going to write that as a minus here, right? And that would be over 125. Okay, and so now these are two fractions, and we can, they have a common denominator, so we can combine this pretty easily into one fraction. All we would do is subtract the numerators and then keep it over the same denominator. So 72 minus 28 would be 30 or 44. I think that's right. 12, yeah, 28 plus 44, yeah, 72. All right, and that is it. They wanted us to express the answer as a fractions so that the answer would be this, and you can't reduce this anymore. So this would be the final answer on that one.